Welcome to the AtlantECO podcast, where we talk about the science behind the AtlantECO project, the Atlantic Ocean, and the human adventures experienced along the way. Here, we have conversations with guests from around the world who work together so that we can better understand, manage, and protect the ocean. So let's embark on the journey of AtlantECO and discover the world that lies above and beneath the surface of the beautiful Atlantic Ocean. Welcome back to the AtlantECO podcast, and in today's episode we get to know the early stage researchers in AtlantECO. So early stage researchers are all the people involved in the project who are in the early stages of their scientific career. So they could be from master's students to PhD and postdocs. And in these conversations, we discover what their research is about and how they contribute to AtlantECO. And today I am speaking with Darshika Manral, who is joining me from the Netherlands. So Darshika, hi and welcome to the podcast. I am excited to hear about you and your research today.
Hi, Louise. Thank you for giving me the opportunity to talk about my research, and it's a pleasure to be here.
It's a pleasure shared. And if you've listened to your podcast before, you'll know that we like to start with a quick word about our guest. So can you tell me a little bit about yourself, and more specifically, where does your connection with the ocean come from? And what has your journey been like from when you started in marine sciences up to now?
Well, it could be a long story, but I'll try to keep it short. I'm currently doing my PhD at Utrecht University in physical oceanography. However, my connection with the ocean and my relation with the ocean started quite later in my life, I would say. I did a Bachelor of Engineering in Information Technology and worked in a company as a software engineer for 2 years or so. And then I realized I enjoyed programming, but I wanted to do something more. So I took a sabbatical. And during that time, I came across an opportunity to work as a field intern for a project studying marine mammals distribution in the Lakshadweep Islands, which are kind of west to the south of India. And it was the first time that I was on a passenger ship going from mainland India to the islands. And I came across this vast, blue, deep ocean. And I was just, awestruck by it. And I barely remember sleeping during those 20 hours because I was on the deck all the time, looking out at the ocean, the sunset, the sunrise, and the night sky, everything. It was amazing. And standing on that deck, looking out at the ocean, I kind of had this feeling that I'm probably not going back into IT. And during that internship also, we had the chance to survey across between islands, and it was all about looking at the ocean. And after this internship, I did a few more, and which got me into a master's program to study marine science, eventually in Europe. It was an Erasmus Mundus program. So I moved every semester from France to Spain to Liège to finally doing my master thesis in Norway. And it was during this whole master's journey that I tried to refine my interests, coming from a different background and doing something entirely new. And it led me to applying my programming skills to study the ocean. And that's how I'm here at Utrecht.
I like to hear those stories of that first encounter with the ocean. Usually there's a story there, So, yeah. And we're going to talk a little bit more about what you do at the moment. If we take maybe like a wide look at what you're doing, so your research, can you explain what it is that you study and also why it is useful to do these kind of things?
So as might have been mentioned in the previous podcast before, that ocean is in perpetual motion. And what I study is how these ocean currents are transporting different types of substances from one place to another over time. And some examples of these substances can be planktonic organisms, plastics, nutrients, heat, and sometimes oil spills as well. And how we do this is by means of Lagrangian modeling. And by Lagrangian, I mean that we study by following pathways of these substances in the ocean. We use ocean model data that are primarily ocean currents, so velocities in the horizontal and in the vertical space and over time, to simulate, that's the good word, to simulate movement of virtual particles. And these particles depict these substances, and we simulate these movement of these particles in the ocean. And using additional data, we can also sample what temperatures, what salinities each particle is facing along its pathways. Essentially, what we get are these trajectories and pathways of these substances, and we can do different types of analysis on these pathways. That broadly comes from what is the research question we are talking about. And the last part was why. So in my opinion, Lagrangian modeling is a very powerful tool. Also because when you combine it with ocean observations, it expands our understanding of what is happening in our ocean currently and how we expect it to change in the future. I think therefore it's quite essential because we can't sample everywhere in the ocean. And these tools can help us really expand our horizon in that sense that you can release particles across the whole ocean and then see where they go.
Yeah, that sounds really interesting. And if we look at AtlantECO, so the projects that you're primarily working into the project, so that's why you're doing your thesis. Can you tell us a little bit more about the specific activities? So what you are simulating in your models, what kind of particles you're looking at, and maybe how also it's going to integrate with the other activities, because it's important to understand that there's so many people doing so many different things. So what you get from other people, but also what your results are going to be used for.
So I think my project stems from one of the pillars of AtlantECO project, the seascape and connectivity, which is about finding how these different components like currents, temperatures, nutrients can help us understand this distribution of plankton species, for example, in the ocean. And in my project, I have looked at how plankton, so let's say water can get transported from one place to another, but plankton are living organisms. They like to live in certain temperatures. And therefore, it becomes important to consider what are these thermal restrictions for these plankton species. And we try to define models. So we use Lagrangian simulations, but what we build is a connectivity network for these plankton species. So a plankton species which prefers, let's say, cold waters, it will not be able to transport across the whole tropical waters and reach the other side of the ocean. So therefore, you can see that there is connectivity in the ocean by water, but there is also some disconnectivity that you can start to observe when you apply these constraints of different living species. And when we have these model outputs, we can compare them to observations in the ocean. And that's where the knowledge from biologists and people who are working with metadata of these genomic data of these plankton species, and we compare what we get in the model and what is observed in the ocean. So I think it's also a way to check our models at points sometimes. It's an exchange of information that will help us build a better holistic view of the ocean. And another thing to keep in mind is that there are multiple constraints. And if we just look at temperature, one individual constraint, we can look at what is the impact of that. But in reality, there is a lot more going in the ocean. In between different species, there is predation. There is a lot more going on there in the ocean. So it's a bit hard, but it can give us a good estimate, I would say.
Yeah, and then once we've got these estimates, these models, these kind of pathways, you can provide that information to people that are looking at maybe spatial planning for the ocean or looking at protected areas or looking at implementing new policies for looking after the resources in the ocean and these kind of things. And that gives them a good idea of how it might evolve or how it might change depending on the different situations and scenarios, I guess. And you can change all of these elements in your models.
Yeah. You can choose like, okay, this species, what are its limitations? And then you try to get what is the network of connectivity that it can have. So it's quite fascinating. These tools can give us pathways. What is the likely pathway that these plankton could be taking, and how much time on an average would they take? So it's quite cool, I think.
Yeah, I want to talk to you a little bit about the future. So what's on the horizon for you? What's your big dreams for the future? Where are you going?
Yeah, so I'm in my third year now of my PhD, and I still have a year to go. So my current focus is to focus on my PhD. And I worked on the model aspect of this connectivity, and I would really like to collaborate with biologists, work with them to improve these kind of models. So that's one of my immediate goals. And after my PhD, I haven't really decided yet, or I've kind of postponed that decision for next year, I would say early next year. But I'm open to being in academia or in a field that is related to ocean research. And one aspect that also appeals to me is science communication. I've already had some opportunities to reach out to general public and sometimes with school children as well. I think it's quite important, and I would like to somehow continue with that as well.
That sounds really good. And more people are interested to really share what they do and how they study the ocean. And it's something that's really important. You know, it's a resource that is amazing for us. And I find it fascinating. I mean, I do these podcasts. It's also a little bit selfish because I get to get these conversations and understand how things work a little bit more. But I think it's important to be able to explain those things to as many people as possible so that they can share that passion or understand a little bit more.
I would like to add that even if you come from far away from the ocean and you've never been there, you can always build this connection. And there are ways now to explore this aspect. And I think everyone is connected to the ocean in many ways. With oxygen we breathe. Not only the trees, right? We have plants, these plankton in the ocean. And we are connected to the ocean. And I think it's important to understand this relationship.
Definitely, I share that point of view for sure. And to end our conversation today, what is one piece of advice you would like to pass on to anyone that is starting their career in marine sciences?
One thing that I would like to say is that given that we are in times of interdisciplinary research, multidisciplinary research, I would say don't be afraid of trying new things. If you're trying something unfamiliar, if marine research is unfamiliar to you, just reach out to the community, and I'm sure you'll find something that you already know from before, and you can try and apply it in marine research. And it's not only reaching out to community that is specific to research, but also people around you. If you convey to your family and friends, I think they all come and help you. For me, it was the case. When I started, my family supported me, my funds to do this master's, and the company that I worked in, they also supported me a lot. And they made this transition from going from India to do a master's in something entirely new. They made it possible for me. I think it's always essential. If you find that you want to change something, just speak it out loud and you will find people to help you out. I have one more thing to say. It's not specific to marine sciences, but it's an advice that I took from a book called Sense of Wonder by Rachel Carson. And the advice that I took from this book was that anyone, a child to an old person, can build their connection with nature, with ocean, by just being observant of the things that change around us, of what is happening around us. Just be observant, and you don't need to know all the scientific jargon to build this connection. Anyone can do it, and yeah.
I think that's a beautiful place to end our conversation today. So, Darshika, thank you so much for taking the time to talk to me and to talk to everybody that is listening. And
thank you. Thank you, Eloise.
Good luck with everything that is still to come.
Thank you. I really enjoyed the conversation.
We hope that you've enjoyed today's episode and look forward to seeing you next time. You can follow the AtlantECO project on our website on www.atlanteco.eu, and you can also find us on Twitter, Instagram and Facebook. All the links and information on the project and on today's episode is in the show notes. AtlantECO is a project funded under Horizon 2020, a European Union research and innovation programme.